Jared Watson. Have you ever wondered what the world would be like if we had longer lasting batteries? Imagine being able to go days or even weeks without charging your laptop or your smartphone. But those are just luxuries. Imagine a battery powerful enough to run an entire car on its own. Well, I'd like to introduce you to the lithium sulfur battery. I'm going to be explaining how switching from the lithium sulfur battery can be cheaper, safer, more efficient, and environmentally friendly than the current lithium ion battery. For those of you who don't know, pretty much all electronics these days run on a lithium ion battery. These batteries emerged in the 1990s and completely changed the way people communicate. But it's not the 90s anymore. See, these batteries were designed with small electronics in mind. For example, it takes thousands of these batteries to power up an electric car, and even then, they still only provide up to 200 miles before needing to be recharged, which doesn't compare well with what a full tank of gas can offer. Now, before getting into the lithium sulfur battery, it's important to understand how the basic lithium ion battery works. And I just so happen to have one right here. This is a standard AA battery that most of you are familiar with. There are three parts to this battery. The first two are the poles, marked with a plus and minus sign respectively. These are called the electrodes. The positive electrode is known as the cathode, and the negative electrode is the anode. The third component of this battery is this part in the middle. This is called the electrolyte. This helps ions move freely inside of the battery. Now that you know the parts of the battery, here's a visual to help you understand how it all works. So, to power up any device, such as this light bulb, chemical oxidation reactions release electrons in the anode. These electrons travel through the circuit to power up the light bulb. In the cathode, these electrons are taken up through reduction reactions, and finally, the electrolyte completes the cycle by allowing the ions created from both reactions to move back and forth between the two electrodes. Okay, so now that we know how the lithium ion battery works, allow me to present a few reasons why the use of sulfur will result in a significant upgrade. First off, sulfur is an industrial waste product that is cheap and abundant. Industries estimate the cost of lithium sulfur batteries to be $200 per kilowatt hour. This is insanely cheap when compared to the lithium ion battery that currently costs $400 to $600 per kilowatt hour. That's literally half the price. It's also worth mentioning that during discharge, each sulfur ion bonds with two lithium ions rather than just one. This is double the number of bonds. More chemical bonds means more energy storage. This, combined with the fact that sulfur is extremely light, means manufacturers can pack more sulfur into the battery. This results in the lithium sulfur battery being able to store 4 to 5 times as much energy per gram as the lithium ion battery. This upgrade can bring an electric vehicle mileage range up to 500 miles on a single charge. This boost would make the number of electric car purchases skyrocket, which would significantly cut down CO2 emissions from gas vehicles. Because of this, the use of sulfur is also environmentally friendly. Now, because the lithium-sulfur battery is in early development, there are a few problems with the formation of polysulfides within the battery. These polysulfides form within the cathode of the battery and create a film-like substance that blocks the ions from traveling back and forth, rendering the battery useless. However, Dr. Kevin Zavadil and his team of researchers are working on a solution as we speak. His plan is to use membranes to protect the lithium surface, which will prevent the formation of polysulfides in the first place. Once this is successful, we will be presented with a newer, cheaper, more efficient battery that will slingshot us into the future and revolutionize the way we use electronics today.